Hi guys, my name is Samuel Jasper. My topic for AIT for elements of electrical and electronics engineering is on parking sensor. What is parking sensor? A parking sensor is an electronic device that helps drivers park their vehicles by detecting obstacles around them, especially in tight spaces. They are commonly used in cars, trucks, and other vehicles to assist in avoiding collisions while parking, making it safer and easier to park in small or crowded spaces. Electronic devices that assist drivers in parking their vehicles by detecting nearby obstacles. It also alerts the driver with audible or visual signals to prevent collisions while parking. Types of parking sensors. Ultrasonic sensors. How do they work? Ultrasonic sensors emit high frequency sound waves. These waves bounce off nearby objects and return to the sensors. The system measures the time it takes for the sound waves to return and calculates the distance between the vehicle and the obstacle. The advantage for ultrasonic sensor is it is of low cost and widely used in parking systems, and also it is simple and effective for short range detection up to 1.5 meters, and is applicable in common in cars for parking assistance systems. Electromagnetic sensors. How they work. These sensors create an electromagnetic field around the vehicle. When an object, example a person, and the vehicle enters the field, it disturbs the electromagnetic waves, triggering an alert. Advantages: it is a non-invasive and hidden installation, and it is also of low maintenance as they don't require frequent cleaning. It is used in parking lots or garages where the sensors are used for general proximity warning. Radar sensors. How do they work? Radar sensors use radio waves to detect objects. The radio waves bounce off obstacles and return to the sensors, allowing the system to measure the distance and the speed of the object. The advantages. It is highly accurate and effective in various weather conditions, say rain, fog, snow, summer, any other thing. It can also detect objects at greater distances from ultrasonic sensors. And the applications are it is often used in advanced parking assist systems in high-end vehicles, and it is also useful in autonomous vehicles for obstacle detection and collision avoidance. How parking sensors work? Step 1. Emission of waves. Sensors typically installed on the front and rear bumpers emit sound waves in the case of ultrasonic sensors, or radio waves in the case of radar sensors. The waves spread outward and traveling through the air until they hit an object. For example, a wall, a vehicle, or a pedestrian. Step 2. Reflection of wave. When the emitted waves come into contact with an obstacle, they bounce back toward the sensor. Reception of waves. The step 3. The sensor receives the reflected waves and measures the time it took for the waves to travel to the object and return. Step 4. Distance calculation. This system uses the speed of sound, ultrasonic or radio waves, the radar, to calculate the distance between the vehicle and the object based on the time taken for the waves to return. Step 5. Alert. When the sensor calculates the distance, the system compares it to the predefined threshold. If the object is within a dangerous proximity, the system triggers an alert, usually a beep sound that gets faster as the vehicle gets closer to the object. Some systems may also provide a visual display showing a graphical representation of the object's location. Types of alerts. Audio alert. We have three types of alerts, namely audio alert, visual alert, and vibration alert. The audio alert. The system emits beeping sounds that increase in frequency as the vehicle gets closer to an object. The second one, the visual alert. Some systems display a graphical map or use a camera feed to show the distance and positions of obstacles. Vibration alerts. In some advanced system, the steering wheel or seat vibrates to alert the driver to to get the driver aware of accidents. Benefits of parking sensors: enhanced safety, prevents accidental collisions. Parking sensors help avoid collisions with objects, pedestrians, or other vehicles when parking, and also reducing the risk of damage or injuries. And it also protects surrounding property. They help prevent damage to surrounding structures like walls, poles, or fences, ensuring safe parking in tight or crowded spaces. The second one, improved parking convenience. It is easier to park. Parking sensors guide drivers in tight spots and difficult to navigate areas, for example, garages or busy parking lots, and reduce stress during parking maneuvers. And it also effortless parallel parking. Sensors make parallel parking much easier by helping the driver detect nearby objects while backing into a space. The third one, it reduces vehicle damage. It minimizes risk of scratches and dents. By detecting obstacles early, parking sensors reduce the chance of scratching or denting your vehicle while parking. It preserves the vehicle condition. It protects both the front and rear bumpers from collision with curbs, walls, and other vehicles. It's also the fourth one, time saving. Faster parking. With real-time feedback, drivers can park more quickly and efficiently, especially in crowded parking areas, saving time and reducing frustration. It has also reduced need for multiple attempts. Sensors minimize the need for repeated parking adjustments since the system provides immediate feedback. Limitations and challenges of parking sensors. Limited detection range, short detection distance. Most parking sensors have a limited range, usually up to 1.5 meters and below that, which may not be sufficient in certain situations. Difficulty detecting distant objects. Sensors may struggle to detect objects that are farther away, reducing the effectiveness in some parking scenarios, such as when a vehicle is parked far behind or when there is a large space between vehicles. False positive alerts, inaccurate alerts. Sometimes parking sensors may trigger alerts when there is a no immediate danger. For example, the system might beep due to objects like trash cans, curbs, or pedestrians that aren't in the direct path. Oversensitivity. Some sensors may be too sensitive and give unnecessary warnings, which can annoy the driver or cause distraction and sometimes cause accidents. Weather conditions. Sensors, especially ultrasonic sensors, can have trouble functioning in rain, fog, or snow. Excess moisture or snow buildup on the sensors can block the signals and impair detection. Extreme cold temperatures can also affect the performance of certain sensors, such as electromagnetic sensors, by causing them to be less responsive. Sensor placement and obstructions. Parking sensors are typically installed on the bumpers, but any physical obstruction such as dirt, ice, or snow on the sensors can block the ability to detect objects. Applications of parking sensors. Automotive industry. Parking sensors are standard feature in many vehicles, especially in higher end models to assist parking and advisory. They are integrated into ADAS, advanced driver assistance systems, for collision prevention, improving vehicle safety while parking. And also it is used for reverse parking assistance. Autonomous vehicles. Autonomous cars use parking sensors as a part of the sensor suite to detect obstacles in the parking environment, helping them park without human intervention. Robotics and automated system. In facilities where robotic systems park cars autonomously, parking sensors assist robots in detecting obstacles and accuracy position vehicles. Parking for special needs. Parking sensors can be especially beneficial for drivers with disabilities or older drivers by reducing the effort needed to park in tight spots and avoid obstacles. Conclusion. Parking sensors have become an essential feature in modern vehicles, significantly improving safety and convenience for drivers. They help in preventing accidents by detecting obstacles during parking, reducing the chance of vehicle damage and collisions with nearby objects. The role extends beyond personal cars, finding applications in autonomous vehicles, smarter cities, drones, and etc. However, like any technology, parking sensors come with their challenges. They have limited detection range and can prone to false alerts and issues due to weather conditions like rain, fog, or snow. Future potential. Technological advancement. Continued improvements in sensor technology will likely address current limitations, including range issues and weather sensibility. AI and Internet of Things integration. Parking sensors are expected to integrate further with artificial intelligence and Internet of Things to create smarter and more efficient parking solutions in both urban and private spaces. Thank you. Bye. Yeah, bye.